Secure AI starts with trust: who users are, what they're allowed to do, and how secrets stay protected. In this module, we'll connect Microsoft Entra ID, Least Privilege RBAC, and Key Vault into a foundation for safer Azure AI workloads. We've moved from enterprise architecture fundamentals through the TOGAF ADM into Azure landing zone design. That gave us the governance, networking, subscription, and platform guardrails needed for cloud delivery. Now we strengthen that foundation by focusing on identity, access, secrets, and encryption before building data, AI, and integration capabilities. In enterprise AI, identity is no longer just a login system. It becomes the control plane for deciding who or what can reach sensitive resources. That includes employees, groups, applications, service principals, managed identities, pipelines, models, and agents. Authentication confirms the requester. Authorization defines which actions are allowed and at what Azure scope. This matters because AI systems connect data, code, services, and automation at high speed. A strong identity architecture turns TOGAF concerns into practical enforcement for governance, security, compliance, risk management, and operational resilience. Microsoft Entra ID acts as the identity control plane shared by Azure and Microsoft 365. Inside a tenant, users are the human identities: employees, partners, contractors, and admins. Groups help manage access at scale, instead of assigning permissions one person at a time. App registrations describe applications that need to sign in or call APIs. Service principals are the local enterprise identities those apps use inside your tenant. Around these objects, conditional access, app management, and governance help ensure the right identity gets the right access under the right conditions. For enterprise identity design, avoid granting permissions directly to individual users unless there is a clear exception. People change jobs, join projects, and leave the organization, so direct access becomes hard to control and harder to audit. Instead, create groups that reflect real responsibilities: platform admins, data scientists, ML engineers, security operators, and business reviewers. Separate those groups by environment, especially production versus development, to reduce accidental privilege escalation. Clear group names, like GRPI prod admins or GRPI dev data scientists, make intent obvious. This also supports enterprise architecture, because access maps back to organization, applications, data, and technology. Applications need identities too, but we handle them differently from users. An app registration is the blueprint in Microsoft Entra ID. It defines how the application can sign in. A service principal is the tenant-specific identity that receives permissions to Azure resources. Traditionally, that identity proves itself with a client secret or certificate, which must be stored, rotated, and protected. Managed identities remove much of that burden for Azure-hosted workloads. Azure issues and manages the credential automatically, so code and pipelines do not need to carry secrets. When available, choose Managed Identity first. Conditional access sits between a sign-in attempt and a protected resource. It evaluates who the user is, what device they're using, where they're connecting from, which app they want, and whether risk signals look suspicious. The policy then applies the right control. Require MFA, demand a compliant device, restrict location, block legacy authentication, or deny access entirely. For AI environments, this matters because model management portals, data platforms, and privileged systems carry high business impact. Stronger policies make access adaptive, not just password-based. When conditions are acceptable, access is granted. Identity governance keeps access correct as people join, move, change roles, or leave projects. The lifecycle starts with a request, then approval, assignment, actual use, review, and either removal or renewal. Access reviews ask managers or resource owners, does this person still need this? Entitlement management packages common permissions for teams, apps, projects, or guests, so access is granted consistently. For powerful roles, PIM adds just-in-time activation instead of standing privilege. Together, these controls prevent privilege buildup and create evidence that access is being governed. Azure RBAC answers a simple authorization question: who can do what and where? The who is a security principle, such as a user, group, service principal, or managed identity. The what is a role definition, such as owner, contributor, reader, or a service-specific role. The where is the scope: management group, subscription, resource group, or resource. A role assignment connects all three. Scope matters because permissions inherit downward. Reader at a subscription can read resources below it. A storage data role on one account, or a custom least privilege role, stays tightly limited. Picture cloud access, like keys in a building. Most people do not need a master key. They need the one key that opens the room where their work happens, and only for the time they need it. In Azure, that means assigning roles at the narrowest practical scope, such as a specific resource or resource group, instead of a whole subscription. Be especially cautious with owner or contributor, because broad permissions increase blast radius. Also, separate management access from data access when services support it. Finally, review permissions regularly so temporary needs do not become permanent risk. Privileged access should be temporary, justified, and observable. Instead of giving administrators standing rights, use privileged identity management to activate high-impact roles only when needed. For sensitive actions, require approval, MFA, a business justification, and a short activation window, such as 2 hours for production access. Separate duties so platform admins, security admins, data owners, and AI engineers cannot independently approve and execute risky changes. Then log every privileged event, alert on unusual activity, and include access reviews in governance reporting. In an enterprise AI platform, RBAC has to balance freedom and control. Platform teams need enough access to run networking, compute, monitoring, and policy controls. Data scientists need safe room to explore datasets and train models, but not to promote changes directly into production. ML engineers can bridge that gap through deployment-specific roles. Auditors and security teams get read-only visibility into configurations, logs, and assignments. The design goal is straightforward: enable each persona without handing out broad ownership. Azure Key Vault is the secure home for sensitive material your applications need, but should never carry around. Secrets are values like passwords, API keys, and connection strings. Keys support cryptographic operations, with protection in software or backed by hardware security modules. Certificates help manage issuance, renewal, and use across services. The main design goal is centralization. Instead of scattering credentials through code, config files, pipelines, and developer machines, applications retrieve them from Key Vault using controlled identity and access. A secure Key Vault design starts with identity, not shared passwords. Workloads use managed identities and Azure RBAC, so permissions can be assigned, reviewed, and removed consistently. Network controls narrow the path. Private endpoints and firewall rules keep access inside trusted networks and block public reachability. Diagnostics close the loop by recording secret reads, key operations, and policy changes into monitoring and alerts. Rotation treats credentials as temporary. Regularly replace secrets and keys before they become stale, overused, or exposed, reducing the impact of any leak. The foundation is now in place. Microsoft Entra ID establishes trusted identities. Azure RBAC turns those identities into least privilege access. Key Vault protects the secrets, keys, and certificates those services depend on. Together, these controls let data and AI platforms scale securely across teams and environments. Next, we build upward into Azure Data Platform Services for AI.